everyone. It's nice to have a lot of people gather around, talk about the overall infra part. When most of us are talking about generative AI all the time. So today, what we'll be talking about is basically MLOps and MLOps on Kubernetes. Especially, how do you build a MLOps platform with Kubeflow? So before we begin, just a short poll, probably a show of hands would work. The first question, who has deployed a ML model in production? Just a show of hands. Cool, not many. Who has already used Kubernetes, that is in context to ML, sorry. Sorry. And the last question, who is already using Kubeflow? No, I can understand the pain. So just roughly going through the agenda, we'll just give a very basic primer on MLOps. We'll dive into the introduction of Kubeflow, the components and the pipelines. And then move on to, and Joinal here would move on to talking about how do you build and run a pipeline. And in the end, we will have some time for Q&A. So before we begin, just to give an introduction about ourselves. Hi, I'm Nikhil, and I have Joinal with me. We both are consultants working for Google Cloud. And to begin with the first topic, that is the MLOps primer. Now, obviously, whoever is working in this field would understand MLOps sits right in the center of these three major, gamut of a software development lifecycle. You have data engineering, you have data science, you have software engineering, and then right in the center you have MLOps. So just to take you through quickly a typical machine learning lifecycle, you start off with your business use case, you do data exploration, you do a lot of experimentation, select an algorithm, run some data pipelines, build them, do feature engineering, build a model, evaluate, present the results to your stakeholders. Once you get a buy-in, you plan for deployment, you operationalize a model, and then basically the time comes for model monitoring. But the production reality is actually very painful. Most of us would understand. So an enterprise machine learning ML code is just one small piece of it. There is a lot of other jigsaw puzzles that we have to put together to make everything work together. I'm sure this is something that is like a known diagram or a known image that people would have known. It's from a paper called The Hidden Technical Debt in ML Systems. That paper was published back in 2015, so almost 8 years. Still very relevant, still a lot of challenges we are trying to sort of tackle when it comes to MLOps. So what do data science or ML engineering teams want? They want faster time to market. They want reliable and stable ML systems. And ultimately, they want to improve their productivity. So this is just, I wouldn't go deep into this. Probably a lot of you would already know. But basically talking about the big blocks, like the model exploration or development, where most of the experimentation happens. And then you sort of, the data scientists would sort of move the code into a source repo where you'll build a pipeline, you'll package the code, and basically deploy the pipeline. And then it moves into a production lifecycle where you would have your CT, which is the continuous training part of updating a model. And then once you're ready with your model, you basically go into the serving part where you would serve it via an API and do performance monitoring on top of it. So now comes the point of Kubeflow, which is what we are here to talk about. This is from a report. So 65% of Kubernetes workloads are part of ML, as you can see. And Kubernetes obviously is a great platform of ML, and I mean these are some of the advantages of why you should use Kubernetes for building your ML systems. But if you want to use Kubernetes for ML, you have to be expert in a lot of multiple things, and it's not an easy job, obviously. Yeah, literally you would have tears in your eyes. So now comes Kubeflow. What is Kubeflow? It's an open source Kubernetes native platform for developing, orchestrating, deploying and running scalable and end-to-end machine learning workloads. It's an open source project supported by a wider community of developers that are and contributors. So just to briefly talk about from a Kubeflow platform, these are basically the major component, or I would say logical component groupings that we see. So on the top, you have the ML tools, where you have all the known ML frameworks supported by Kubeflow. Now, the good thing about Kubeflow is Kubeflow sort of makes aware these clusters of different execution nuances of each of these ML workflows. For example, if you want to scale it on multiple nodes, or if you want to use GPUs for a specific node for training any of these frameworks, it takes care of that. In the middle, you have certain applications that are there in the backend. Now, some of it I can highlight, like for example, Istio, it sort of supports the entire microservices architecture by providing functionalities like user-based access control for your endpoints or resources. You have Argo workflows to sort of orchestrate and do continuous integration of these pipelines. You have Prometheus to do the logging and monitoring of all of these components. And there are many for serving. You have KF serving, KServe, which is KServe now. You have PyTorch, you can use Seldon, etc. For hyperparameter tuning, you have Katib, which basically uses the state-of-the-art Bayesian optimization. And this is obviously built on top of Kubernetes microservices architecture. And then on the bottom, you have all the platforms and clouds, be it any of the cloud providers, or you want to run it on-prem or on a local machine. So now enters Kubeflow pipelines. Obviously, that's where we would sort of work around and sort of build these pipelines, build these ML solutions. Now, what does Kubeflow pipeline offer? It offers a UI for managing, tracking your experiments, your runs and jobs. It offers an engine for scheduling your ML workflows. It also has a SDK for defining and manipulating these pipeline components. And then you have a notebook interface for sort of interacting with the system using an SDK. So in summary, what Kubeflow pipelines does is basically it enables workflow orchestration. It helps in reusability of components, and obviously it helps you in rapid experimentation. Now, what constitutes a Kubeflow pipeline? Now, what you see these blocks on the right-hand side, these are basically nothing but components written for a specific task in an entire ML lifecycle. And what Kubeflow does is basically it does the containerized implementation of each of these tasks. And each of these tasks could sort of trigger an individual service. For example, it could a specific component could trigger a Dataflow or Apache Beam or a Dataproc job that does a lot of data processing. You basically do all the specification in terms of the SDK via components. And obviously, you have the option to pass on parameters, arguments to the entire pipeline or within the components. So just a visual depiction of a typical pipeline in Kubeflow. So you start off with your data pre-processing and validation. And this is how it looks like in the UI. And then you move on to your feature engineering. And then if you want to run or train models in parallel, you can do that by defining in the same way in your pipelines. Then you have your model validation, where you basically choose your best model, and then comes to the deployment or the serving part of it. So now Joinal will sort of take you through the steps in how do you build and run a typical Kubeflow ML pipeline.
Thank you, Nikhil. Before I dive into this, right, where anyone was part of the workshop that we run just pre-event, and that was a 3-hour long workshop just on this, on how you build or deploy an ML platform on Kubernetes and the news, right? So I'll just skim through things. Today, obviously, because I just have 15 minutes, I cannot deploy a Kubernetes cluster and top of that run Kubeflow, right? So before that, right? So this is how a Kubeflow pipelines architecture looks like, right? If you just do it at top level, there are these YAML pipeline definitions that are available to your, data scientist or your ML engineer to configure these jobs, right? And at center, there's this ML API servers that runs your jobs, your iteration, training runs, your pipelines that you configure just we saw earlier, right? And these pipelines are similar to the Airflow DAGs that we all have seen, right? So these are directed acyclic graphs, and each subsequent step is dependent on the previous steps. And then, with the Argo workflow, you can, have these multiple pods where a lot of these work is running, and you also optimize your infra in some way, right? So just to skim this down, so this is what pipelines SDK gives you out, right? So it is in Python that gives you an SDK to author your components. So for example, in Kubeflow contrib, you have a lot of these pre-built components available for you to directly take them and build a pipeline. What happens? Let's say you need a custom container or a custom pipeline that reads your data from an on-premise data store, right? So then you use the same SDK to write that component for you, and then that becomes a part of your pipeline. Second is that once that you have these pipeline ready for you, it's similar to Airflow pipelines, you can now reshare or rerun a lot of these components across multiple workloads. So let's say you have a larger team, you can reshare these components for the other teams to run. And then, yes, we data scientists love Jupyter notebooks, right? So it also gives you a good way to orchestrate these Jupyter notebooks and use for your pipelines. So it starts with you writing this component and pipeline code, which essentially becomes then your, you either write containers or YAML specs that then ultimately becomes a pipeline, and that you can run on your Kubernetes cluster. Yeah, so this is how, an anatomy of, let's say if you take just one component, right? So you start with simple, the same we used, right? So start with defining what is the container operation that you need to run on, and then what is the exact container, right? Which container that you want to use for this specific step. You also give an entry point that, when this container comes up, what exactly needs to run there. And what are the outputs that this container generates, so that then the pipeline knows, okay, from this container, this is what I want to run, this is the output I'm expecting, and then I'll pass this output for the next step. Yeah, and then there are these runtime parameters that you can then configure a part of your pipeline and pass into it, right? So think about, you created one pipeline that orchestrates your training flow, and then for each run of the pipeline, you pass runtime parameters, maybe different hyperparameters, different data points to run on, or maybe different architectures that you want to try. Yeah, so in this case, there is this sequential pipeline that takes the runtime parameter of a specific data and then trains your model on that, right? And you can also have some of these, implicit task dependency assigned on that pipeline to test for those. Yeah, this slide looks a bit busy, but there are, essentially this is what it looks, right? So if you look at the pipeline, Python SDK, you write your pipeline like this. So initially you start with create cluster operation. This is the first step, and you pass on all of these things, like the cloud project or the region this needs to run, what is the, for example, container needs to run, and that becomes one step, right? So at first you have one step that calls create the cluster. Once the cluster is created, then you have additional step, next step is analyze. So you assign that analyze step, they are saying this is an analyze operation, this need to run this specific runtime parameter on that container. And similarly, then you write the whole pipeline, and this pipeline will now look like this on your UI, right? And what this UI gives you flexibility is to look at each of these operations individually and see what was running, what is log generated, what is my output that I got, right? And then you can also maybe decide to, let's say, I don't want to do analyze, transform, train every time I run this, right? This was done once, and then you can just, from there, you can just click on predict and start your pipeline runs from there, maybe for your production use cases, and then go downstream. Now let's say you know how you created the pipeline, right? You have a pipeline, but where I should run this, right? What can I use this for? So let's look at a typical user journey, right from, let's say, a data scientist that wants to train a model. So you start with installing Docker, create a container. So, for data science folks, the Docker configs are very easy, like simple, right? We don't want to do a lot of things. It just helps me to create a container, that's all, right? I don't want to do a lot of fancy things there. So I created a fork from TensorFlow 1.7, added my grid model to it, and then said, whenever this container runs, I need to run this script in that container. Then I do a push to my the container repository. Okay, this is my container that I've created. Push it to my repository, and this is where the TensorFlow job is running, right? So we start with gcloud auth, so that my container can now authenticate with my cloud account, and then there I create this repo where my Kubeflow pipeline code is there. I then create that repo, right? Once that is done, that is where I now create certain parameters which has the container image and what should this be called. Then I say, ks generate tf job, and this is my grid model. So this is now will generate a tf job which can then be seen on the Kubeflow UI. And then finally, once this everything done, I now submit my job to my Kubernetes master, so that the master can orchestrate the job and run my distributed training for me. And this is how it looks under the hood, right? So the user first comes in the container, authenticate its own IAP, and then it comes to this API gateway or ambassador service, right? Now what this does is launches this. The first is when I am working on the Jupyter notebooks. So via the Jupyter Hub service, it creates a Jupyter Hub and helps me to do a lot of simple, quick R&D work, right? Once that I done, I submitted a new Kubeflow training job, and then this will run. Create a TF master node, and then along with that, it will create a lot of parameter servers and workers, so that the model gets distributed across a lot of nodes. Now I have a container, a model that is trained, right? Now what's next? Once I have that, I can leverage something called as in kfserve. And what kfserve does for me is orchestrates away the training steps to, steps to deployment, right? So if there are ML engineers here, you might know that deploying a TensorFlow model is very different than deploying a PyTorch model or deploying a sklearn model, right? And kfserves orchestrate in such a way that you just need to write a kubeconfig saying that this is my model, this is what it resides, and this is a TensorFlow PyTorch, whatever the model is, right? And then kserve takes care of the orchestrant parts. It will orchestrate the model as an endpoint and it will give you that. Once you do that, again, there are these steps, right? So I first create a generate, serve my grid model component and give it a name, give the model path where the model stores in. For this example, we have stored a Google Cloud Store, but you can use, for that matter, anywhere the model is stored, right? And then you apply apply Kubeflow, serve my grid model component, and then it creates an endpoint for you that you can then leverage, right? If you have to scale, then you can add how many replicas I want, or maybe if you want to go for a canary deployment or any of the major, you can do that. Same here, this is how it looks under the hood, right? Earlier we saw it creates a master node where it orchestrates the training job across pods and parameter servers. Similarly here, then it creates a lot of these training service pods, and each of these service pods are now addressing to all of your API calls that is coming in. So this was code that we used for the workshop, so I'll not run there, but if you want to access it, just scan this QR code and give you a lot of code labs for you to learn and see how this is in action. I'll just give 1 minute for this. Done? Some show of hands, please. Done? Okay, cool. So this is how you'll learn there, right? So from training, how do we create that container, deploy it on GCR, create a cluster on GKE, and then do your training, and then for deployment, you create on the cluster, you create a deployment, and use a load balancer that exposes your endpoint to internet, and then you can send all the traffic there. To summarize, this is what we wanted to talk about or summarize today, right? So this is how today, even though we have seen that paper coming in 2015, and still, this is how ML is today, right? You have this lot of manual steps for going to production, and how Kubeflow pipeline or Kubeflow solves you is to make sure that you build this reproducible or reusable components, right? Then you can just rerun the same thing whenever you want to do a continuous training of your model, maintaining them on production, and then quickly go to market. I think that was all, and I hope some of us are feeling like this, they at least know how to use, even if you don't go on depth, but at least how to know how to use Kubeflow for the ML models.
Can we run Kubeflow with cloud TPUs as well?
I assume yes.
I think, yeah, we
Have
do
to check
have
on that.
support, yeah.
Any other question? Yes.
Just to answer that, right? So Kubeflow, you can deploy it on your own in a GKE and then manage it for your own. But you also have Vertex AI, which takes a lot of these in like managed service that does it for you, right? So you can directly use Vertex AI to like use TPUs for a deployment.
Okay, first of all, great talk. Thank you so much. So my question is more on the ML flow side. You said that we can technically just use the same set of settings and containerize them. That's where the Kubeflow help us. However, every model is in essence different. So how would the same hyperparameters, let's say, or the set of hyperparameters that we are using, going to help us if we are just applying them in a different model?
So what I mean reusability is not using the same set of hyperparameters. You create a pipeline that does the training for you, right? So you want, let's say you want to train an object detection model and you fixed on maybe using VGGNet, right? So now you create a pipeline that uses VGGNet. And once that is done, you apply a lot of these hyperparameters to that existing pipeline so that now you can orchestrate multiple runs with various set of hyperparameters that runs parallelly and trains the best model for you, right? How Kubeflow can additionally help you is use Katib. So then Katib used state-of-the-art Bayesian optimization to find out what is the right hyperparameter for that case.
Awesome, thank you.
Thank you.